Let's take a look at example 5.29. A 45 kilogram crate of tools rests on a horizontal floor. You exert a gradually increasing horizontal push on it and observe that the crate just begins to move when the force exceeds 313 newtons. After that, you must reduce the push to 208 newtons to keep it moving at a steady 25 centimeters per second. Okay. So when we're talking about friction, there's two types of friction. There's static friction, kinetic friction. Static friction is when it has a range. It goes from 0 up to a maximum value. Kinetic is always a constant value. So they told me that I can start pushing with 0 and I can push all the way up until 313 newtons, at which point it starts to move. So they are telling me what the maximum static value is. So they're telling me that mu sub s times normal force equals 313. Then if I apply a constant force of 208, it's going to move at a constant velocity. Well, constant velocity tells me that the force applied and the force of friction have to be equal. So now they're telling me that mu sub k times normal force is 208 newtons. So in order to solve for these mu values, for my static situation, I have mu sub s times the normal force equals 313. And for my kinetic problem, I have mu sub k times the normal force equals 208. So in order to solve for these two mu values, I need to first find my normal force. So I come over here and I say the sum of the forces in the y direction is 0 because it's not accelerating off of or into my surface. So I have normal force minus mg equals 0. And so I see normal force is equal to mg. They did tell me the mass was 45 kilograms. So I can make those substitutions here. So I have mu sub s is equal to 313 divided by the normal force, which is mg, 45 times 9.8. Same kind of thing here. Mu sub k is going to be 208 divided by 45 times 9.8. Noting that my mu sub s is always larger than my mu sub k, should be a number somewhere between 0 and 1. If I plug these two values in, I get a mu sub k value of 0.47. Interesting side note, remember, no units on that one, does not have any. And I get 0.71 for my coefficient of static friction. So those are my two coefficients of friction. Then the problem says, well, what if what push must you exert to give it an acceleration of 1.1 meters per second squared? Okay, so as soon as I hear that it's accelerating, that there's sliding between the surface and my object, I automatically know which type of friction I have. I have kinetic friction. All right, so let's set this up. It's going to accelerate this direction at 1.1? Yep, 1.1 meters per second squared. So I go ahead and I sum up the forces in the x direction. It's going to cause an acceleration, so it's equal to ma. I have force minus the force of friction equals ma. And so the applied force is going to be ma plus that force of friction. Now in this case, it is a kinetic friction, which I know is a constant value of 208. So I can then plug in those numbers of 45 times 1.1 plus 208. That will give me an applied force requirement of 257.5 newtons as the required force to cause that acceleration. Again, if there's an acceleration, anytime there's sliding between those surfaces, we're using the kinetic friction. There you go.